All right, welcome to lecture 23. Like most of the lectures, there's three parts to it, A, B, and C. This lecture, we're going to move on to a totally different topic, totally unrelated topic to what we're talking about, right? So in the last couple lectures, we're looking at molecules and what they look like and how we can imagine their shape and so on. So in this lecture, we're moving on to gases. So we'll talk about first off in this lecture what is a gas and specifically look at one of its important properties, which is pressure. And then really most of what you're going to hear about is how different properties of a gas relate. So in the next part, we're going to talk about how pressure and volume of a gas relate. And then in the last part, we're going to talk about how temperature and volume of a gas relate. So when I say relate, that really means to be able to calculate how one thing changes the other thing. So yeah, we're back to doing a little math in this chapter. All right, so bust out your calculator. You're going to need it again. All right, with that, let's go and get started. So first off, we're going to talk a little bit about what pressure is. Okay, so we're going to talk a lot about different properties of gases. We'll talk about the volume of a gas and the temperature of a gas and I don't know, all kinds of things. Now, those things you've heard a little bit about already, right? Like volume and temperature. The one property, and it's probably the most important property for a gas that you haven't heard anything about, at least in this class, is pressure. So what is pressure? Well, it's another property of a gas, and to be a little bit more specific, it is force divided by area. It's force divided by area. All right, that's what pressure is. So force is basically weight. It's weight divided by area. So one way that we kind of know this is, or we run into this, is maybe like thinking about your car tires, all right? If you think about your car tires and you have to inflate them, you know, they go flat after a while. When you look at your car tire, and let's see if I can draw a car tire. I'm not very good at drawing, so let's make this like the rim. And then, you know, you got your car tire, right? I don't know. That look, sure, that's a car tire. When you look on your car tire, you're going to see usually there's a little thing on the wall or inside of the door, and it'll say inflate this tire, and it'll say inflate this tire to maybe 35. And then, you know, there's always a unit. Inflate this tire to 35 what? Well, it'll say 35 PSI. So what does PSI stand for? So PSI stands for pounds per square inch. Pounds per square inch. So that kind of gets back to that equation I put at the top. If I asked you how much you weigh, you might tell me I weigh so many pounds. And then if I asked you about area, we measure area in square units, square feet, square yards, square meters, or in this case, square inches, square inches. So that's what PSI stands for, pounds per, that's kind of what the line is, pounds per square inch. So how does that relate to the car tire? Well, what you do when you inflate the car tire is you force a bunch of air into that tire, right? And the air molecules, they're not just sitting there, they're moving around and they're hitting the walls of the tire. They're hitting the sides of the tire, the inside sides of the tire. And when they hit the inside sides of the tire, they're pushing on the tire, the walls of the tire. And they push with enough force so that on every 1 inch by 1 inch piece, so you know that's not very much, like an inch by an inch, right? Like maybe like that. On every 1 inch by 1 inch piece of the tire, they're pushing with 35 pounds of weight, 35 pounds of force. All right, so you see pressure kind of maybe like tires, bicycle tires or car tires, you have to inflate them to a certain pressure. One other place you might run across pressure is they also talk about pressure in the weather, right? So if you watch the weather, if there's a storm coming in and you're worried about is it going to rain a lot or not rain, one way they can tell that is that when storms come, they also bring with them lower pressure. So typically, if it's going to be a rainy day, the pressure will be lower than on a sunny day. So where does that come from? Where does that pressure come from? Well, basically, let's say you're standing down here in Ventura, all right? Well, you know, above you for miles and miles and miles, there's air, right? There's air above you. And all that air, which, again, is mostly like oxygen and nitrogen, all that air is actually pushing down on you. It's pushing down on the table. It's pushing down on, I don't know, everything in your house, your floor, whatever. So all of those molecules together, as they're getting pushed down by gravity or pulled down by gravity, they are pushing on you. Now, you don't feel it or think about it, but there is actually weight from the air pushing down on your head right now. Well, how much weight? Well, on a typical day, the air above us is pushing down on us with a pressure of 14.7 psi. So on every 1 inch by 1 inch piece of you, like, that's not much, a little bit of your arm, there's 14 pounds of pressure, okay? So that pressure, it can change depending on when the weather changes. All right, so with that, let's talk a little bit about how we measure pressure. So when we measure pressure, the way that pressure is measured is using an instrument like this on the side here. This instrument is called a barometer. So we have them in the chemistry labs. You'll find them in all kinds of like science labs. And barometers are a really old instrument. They were invented. All right, so I write a little note here. They were invented by an Italian chemist by the name of Torricelli as a way to measure air pressure. And he invented this almost 400 years ago in 1643. So how does a barometer work? Well, the way a barometer works is basically there's going to be like a little pool of mercury. So that's what this is, a little pool of mercury. Now, let me ask you, maybe you remember the symbol for mercury. Mercury is Hg. So there's a little pool of mercury down here. And in this pool of mercury, they've put a tube that is open at the bottom end, but then it's sealed at the top. And not only is it sealed at the top, it's actually like a vacuum. So there's no air up at this top. So there's like a little gap up there where it's a vacuum. And what happens is, just like I talked about how air is pushing down on you, on your head and on your arms, and air is pushing down on the table in front of you or wherever you're sitting, the air is also pushing down on this pool of mercury. So air is pushing down on that pool of mercury, and what it does is it causes the mercury to rise up this tube. So the mercury will rise up the tube. Now, depending on how much air there is pushing down, because it could change on a clear day and a stormy day, depending on how much air is pushing down, if there's more air, the mercury will go further up the tube. So one way to measure the pressure is you just measure how high is that column of mercury getting forced up. So air pushes down, that makes the mercury rise up. You got more air, the mercury is going to go up higher. So on a normal clear day at sea level in Ventura, the air would actually, the mercury would actually be 29.92 inches tall. So there's just like a ruler next to this thing, like, a little inch ruler, and you measure how tall is it going today. So on a normal day, that column of mercury goes 29.92 inches high. Now, to be a little bit more exact, inches of mercury, right? Because we're measuring the height of the mercury. So that's going to actually be a unit of pressure. One way to measure pressure, we also measure pressure, we already mentioned PSI, right? That's a unit of pressure. And another unit of pressure is inches of mercury. So 29.92 inches of mercury. So again, that's like on a normal day. Now, that ruler that's measuring how tall the column is, it could also be marked off instead of inches. That ruler might be marked off in centimeters, yeah, once in a while. But it also can be marked off in millimeters. So on a normal day, that column is about 760 millimeters tall, millimeters of mercury. So that's another unit. These units basically have to do with how tall is that tube of mercury. So by the way, 29 inches, if you're not sure how big that is, 29 inches, it's about, what, 2.5 feet. So it goes up pretty good ways. It's about 2.5 feet. All right. So with that, let's spend just a few more minutes talking about, in this video, talking about units of pressure. Okay. So there's lots of units of pressure. I've already mentioned 3 of them. PSI. You'll see that on your bicycle tires, your car tires. There's 2 right here that kind of have to do with the way this instrument works. How tall is that column of mercury? Inches of mercury, millimeters of mercury. But there's a lot of other units of pressure. All right, so let me flip over and we'll look at some other units. All right, let me flip over here. So there's a lot of units of pressure. All right, there's a lot of units of pressure. So let's just go through some of the ones you're going to run across. Now, I should tell you this chart that you're seeing in the top corner here, this chart, it's going to be available on Canvas as a PDF because you're going to need to convert a lot between different pressure units. So you might want to download it and have it handy when you do your homework or whatever, okay? So let's just run through some of them real quick. So some of these you've heard of already, some of them not yet, okay? So one unit of pressure that we use a lot actually in chemistry is atmospheres. And I should tell you, all these units of pressure are equal to each other. So 1 atmosphere is the same thing as 101,325 pascals. Pascals, and actually there's another one that's related, kilopascals. Those are used a lot in engineering. So 101.325 kilopascals. All these are equal. Another unit we're going to run across, a couple of them are based on the way that barometer works, right? So these units, these numbers are also the same thing as 760 millimeters of mercury, which is the same thing as 29.92 inches of mercury, which is the same thing as another unit of pressure is called torr, named after the guy who came up with the barometer. So 760 torr. And then we have our unit of pressure that is, you see on your bicycle tires and car tires, pounds per square inch, 14.7. All of these are equal. And then there's another one, which is called millibars. And I just realized I forgot to write the symbol here. MB, it stands for millibars. 1,013.25 millibars. So all of these numbers are equal to each other. All these pressures are equal to each other. And we can use this to convert between any 2 pressure units. So we're going to do a little converting. One thing I'll tell you is that when you convert, you can always do these problems in 1 step. You're never going to need to do 2 or 3 steps. You can always do it in 1 step. All right, so let's do a little example. Let me erase some of this. So one place you see people talking about pressure is in the weather. All right, so right now, I don't know when you're watching this, sometime after today, but today is actually October 28th, Wednesday, October 28th, 2012. I have no idea when you're watching this. Maybe you're watching this 10 years from now. I have no idea. All right. So as I am speaking, about an hour ago, a hurricane just struck New Orleans. So hopefully it didn't cause too much damage. I hope not. So it was called Hurricane Zeta. I guess it's still called Hurricane Zeta. And one way that they can tell whether a hurricane is going to be dangerous or not is they measure the pressure. And the lower the pressure is in the middle of the hurricane, the more potentially dangerous this hurricane is. So they fly these planes into the middle of the hurricane, and depending on what number they get, they can give them an indication of how dangerous, how much wind to expect from the hurricane, and so on. This hurricane actually, the pressure just changed really rapidly. So you may not have heard about it too much in advance because a day ago it really wasn't that low, but it's actually gotten really low all of a sudden. So it didn't give people a whole lot of time to prepare because it didn't seem like it was going to be that big a storm, but now it is. The pressure in the middle of the hurricane, I just checked on the web, and maybe you can see it there. It's right here. Is 975 millibars. When they flew the plane into the middle, that's what they got. Now, what if you wanted to know that pressure, not in millibars, MB? What if I wanted to know that pressure in, let's say, torr? All right. Well, it's converting. So mostly it's going to be like what we did before. Oh, how did we always start? Write down the number you're given. Write down the unit you're going to. In the middle, we're going to put a conversion factor. Now, we do have to do a little setup of our conversion factor, but it shouldn't be too bad, okay, I hope, because all these numbers are equal to each other. So you can just set any two equal to each other. So we're going to pick the two on the list that I'm worried about. I'm starting off with millibars. I am trying to go to torr right there. So I'm going to make those two, I'm just going to say they're equal to each other. So we'll say 760 torr is the same thing as, I could set it equal to anything else on this list. I only have to worry about the millibars because those are the ones I'm working with. It's the same thing as 1013.25 millibars. So I'm not going to say anything about inches of mercury or pascals or anything else. The other ones don't matter in this question. The only ones that matter in this question are torr and millibars, because that's what you're converting between. All right. So you just set any two on the list equal to each other, and you should be fine. All right. So now it's kind of like what we've been doing for, gosh, all semester, right? You know that you're starting off with millibars. So to get millibars to cancel, you put it on the bottom of the next step. You put the number off the chart that's with millibars. Oh, you can see it here as well. That's going to be 1013.25 millibars on the bottom. And then you put the other one, the one you're solving for, on top. So that's going to be torr, 760 torr. All right. So with that, let's go ahead and work it out. And actually, I didn't do this in advance. Oh, bad teacher. Let me do it right now. I have a calculator handy. 975 times 760 divided by 1013.25. In the torr, the pressure is 731. All right. If you're worried about rounding, most of these numbers on this list, they're like exact values. So for rounding, if you start off with, I guess this is 3 sig figs, you're going to give me 3 sig figs when you're done. All right, so it should be, yeah, that looks right, 731 rounded. All right, so we'll do one or two more in this video. All right, let's try another one. So you can use this list. You can go between any two units of pressure. Just focus on those two units and set them equal to each other, the units you see on this chart. All right, let's do another one. Okay, let's do another example. So this one, it says an automobile tire has a pressure of 31.0 psi. What is this pressure in inches of mercury? All right, so we're starting off with a pressure of 31 psi, pounds per square inch. And I want to know the pressure in inches of mercury. So again, we can do all these in one step, I promise. All right, so you're only going to need like one set of blanks forever in this chapter. So let's go ahead and next thing we got to do is find our conversion factors, and we just set them equal to each other. So we have, let's see, we're starting off with PSI. So that'll be 14.7 PSI. And I am trying to convert to inches of mercury. That'll be equal to 29.92 inches of mercury. All right, let's see if you can help me a little bit with this one. What number are you going to put on the bottom? 14.7, or are you going to be putting 29.92? What number goes on the bottom? Should be 14.7. Why? Because I need PSI to cancel. So if you put PSI on the bottom, go away PSI. That makes the 14.7 go on the bottom. So yeah, that looks right. The PSI is going to cancel. And then on top, you're going to have to put the other side of the conversion factor, right? So that's going to be the 29.92. So we'll put that on top. So this is looking pretty good to me, right? Why do I say that? Because PSI cancels, and I'm left with inches of mercury. All right, with that, let's just make sure you can work it out. So go ahead and type this in your calculator. Tell me what you get. While you're doing it, I got to do it too, actually. All right, I want you to do the question. What's the answer? And make sure it's rounded. Okay, So I gave you 3 sig figs. 31.0 actually has 3 sig figs. So you should be giving me 3. And if you round, it would round to 63 point, what I get? 63.1, rounded correctly. All right, with that, hopefully this is not too bad. Let's just try one last one. This one we're just gonna make a little pop-up. All right, so one last one on this topic. Okay, so this one, let's see here. Let's say I wanted you to convert, oh, wrong question. Let's say I wanted you to convert 35.5 PSI to kPa, kilopascals. One of those is the right answer. You can pause this video for a minute if you want. Which one's the right one? It'll pop up here in a minute. Is it A, B, C, D, or E? Okay, hopefully that worked out for you. Hopefully this is making sense. If not, you can contact me. I can show you some more examples. With that, we'll move on to part B when we talk about how pressure relates to other properties of gases. So that'll be coming up in the next section.